All right. So in terms of like OLTP material, right? This is what we've been working with, right? Meaning that like when we've been designing databases, when we do those data modeling problems, when we have the structure of the tables, right? That's like uh, the way that we're designing tables is for really like a web application or like a typical you know yeah, I guess you could say like web application or any kind of consumer facing application. All right. So for example, like this is the way like Facebook, when you use Facebook, like this is the way like they develop. They're designing their tables or any application. It could be Instagram, it could be Amazon, uh, it could be Citibank. It doesn't really matter what it is. If you're clicking on the website and you're submitting a form or interacting with it or checking your bank account, right? Like what they need to worry about is that, well, there's like tons of users, right? There's lots of users making lots of changes to the database. All right. So this is kind of one thing that they need to worry about and then optimize for. A second thing that we'll get to in a later on is they need to worry about the fact that like what the user did when they say sign up for Citibank or withdraw information. Well, that is like this. That is like the statement of record, right? That is like that is where this information is recorded. Okay, and like we used to call it like the database of record, or but one thing that we want to make sure of is that there's only a single source of truth, right? If we're quickly changing all this information, if the information that we're capturing and the transactions that are occurring when someone clicks on something or submits a form or whatever, if that needs to be recorded, we really only want to record that and make that change in one location, because inevitably, if instead that information needs to be, like say, a withdrawal from a bank account needs to be recorded in multiple spots, inevitably the code will forget to do that in multiple places, right? Like we've kind of seen this with dry, right? The concept of dry, which means like don't repeat yourself. Single source of truth is slightly different, but it comes, I think, from like a similar philosophy, which is, if we're recording information, bad things will happen if we record information in more than one place, right? If we have two columns that essentially capture the same thing, because these will get out of sync, right? You're gonna forget, or maybe there will be an error that just happens in the hardware where one piece of information doesn't match the other, and then the question is, okay, which do you follow? What's more likely is you'll just forget that this is actually recorded in two locations, and the code will not update both spots, right? And so it leads to like being bug prone. So like single source of truth is like the big reason for me of why of like what we're going for when we design tables, right? We want to make sure that we're not having our information captured in multiple spots. And we can, as we go on, I'll show you examples of that. And then the other reason is, okay, this is a customer-facing application database, right? And what that means is when someone submits a form or sends a tweet on Twitter, right, eventually, pretty quickly, that needs to be stored in the database, so that then when someone else visits Twitter, they see that, they access the database again, essentially, and they see that information. So those transactions, that posting a tweet or withdrawing money from your account, right, that has to happen quickly, because then the next person's posting a tweet. So we need allow for high throughput, essentially. Okay? And what that means is we need to optimize for transactions, for actual, like by transactions, I mean people either making modifications to the database, like the end user, submitting a tweet or deleting a friend or adding a friend, right? These are all transactions. So we need to optimize for there to be like a good amount of transactions. And the way that can be achieved is by having like small tables, which is what we've been advocating for anyway. Like have tables that only have, by that I mean tables with a few number of columns, right? Only like 5 to 7 columns, okay? This way, when you say add a tweet and you have like the text of the tweet and maybe the user ID and maybe the timestamp, well, these are the only like 3, or maybe there's a few other things, like maybe if it's public or private, I don't know. But there's not too many fields that you'll need to update, right? When you create a new row. It's just these 3 things, we're done, on to the next tweet, okay? So these are like two large reasons for in an OLTP, meaning, right, by OLTP, we mean a database that powers a like consumer-facing application. That's kind of what I mean. And what this stands for is online transactional processing database. All right. But this is kind of the way you can think about it. The database is that when you visit the web, you're interacting with, right? They need to optimize for lots of users making changes, and then kind of like more importantly to me is that we are only recording data in one spot. Okay. You can see like this is what we've been doing. If you like, if you look at like the Pagilla database, right, like our actors table, it has like the ID, the first name, the last name. When we updated it, like that's kind of some metadata. That's basically it. Like 3 columns, really like 2. This was like the roles. This like film actor thing was just like a few columns, right? All of our, just the same way our classes are small, right? Our tables should be small. One other thing to mention about like thinking about the structure of the data, this is really nice kind of rule, and it's worth going through. Every non-key attribute in a table must provide a fact about the key, the whole key, nothing but the key. So what does that mean? They're talking about like in the actors table, everything that's non-key, like you can think of like text, right? This is neither a foreign or a primary key, right? Not a foreign or primary key. This is kind of metadata, but also not a foreign or primary key. Provides information about the key, right? Meaning this actor, and nothing else. Okay? So, right, so you can always like look at this, and then this should point to the actor. You may imagine, right, we can use a rule like this. If you think about like a films table, we have, 1 maybe is the ID. So this is the key that we want to point to. And then let's say we have like the title. So this would be the ID, the title, the Shawshank. And then, maybe you have the year, right? It is like 1990. Now, if you put like, if you say you have the actor name, right, all of a sudden you tend to be violating it, right? Because this is not only about the film now, right? Every non-key attribute must provide a fact about the key and nothing but the key, right? And now we're providing a fact about an actor, right? So you can see that this rule kind of enforces single source of truth, right? And makes sure that we only are capturing this information about an actor name or about an actor only on the actors table, right? Every time you're like, wait a second, this is not just about this entity, but something else, right? We're violating that rule. Okay. Like right now, like I've been, when I go in technical interviews, or like, I guess not that I do now, but I guess like 8 years ago or something I did. I always thought it was fair for people to ask me data modeling questions. Now that I'm like doing some interviews, I'm asking people data modeling questions. Like I think it reveal to me like, yeah, like they're both practical. They involve kind of like thinking. They have a huge impact right on the design of a system. And it relates to like object orientation or just how you think about organizing an application. So I always think this stuff is like fair game and useful for you to practice and think about. Let's see, anything else? I think that's about it. So the main thing, OLTP databases, they are the transactional databases. It's really, it describes more the design of the tables than anything else. It is not, it relates to the software, but really, like when I think about it, it is, it's how we structure the tables, all right? And generally, this tends to be smaller tables, right? Like meaning only like 5 to 7 columns. You can see a lot of these were fewer, right? 4 columns. We care about single source of truth. And remember that quote about every non-key attribute must provide information about the key, the whole key, and nothing but the key. And that like reinforces this single source of truth idea. Questions about this? This is kind of the data modeling that we've been doing, but maybe we haven't defined it so much about as an OLTP. All right. So essentially what happens is, let me see if you can, nope, okay, I have to stop sharing and then you can restart. Okay, so essentially what happens is, a user, this is like let's say this is their computer. And then they have a form and they put in their tweet, That's supposed to be a smiley face. All right, so they put in their tweet, and that goes to the database, right? And this is our OLTP. Okay. Now, and this is for, as we said, end users to view, to just interact, to actually be able to view this tweet later or see their friends, right? We have to access the database to do that. Now, ultimately, Twitter becomes big enough that, we need to figure out, okay, what kinds of tweets are people making, and what types of tweets do people respond to? And there's all this kind of analysis that, the company wants to do. So because you don't want to perform these queries on this transactional database, because, where one, we don't want to tax the database any more than we need to. We have end users already taxing it enough. Two, we want to kind of make sure that this that we're not messing with any of this data, right? That we're not altering any of it. And then three, as we'll see, we may want to structure. There's going to be tons of tables here in this OLTP. Everything that's necessary to make this database run, right, to make this application run, needs to be captured in our OLTP database. But in our analytical database, we only need the data relevant to analytics. And if you're, say, someone in marketing, or you're someone in business, or even data science, listen, Twitter's application, it probably has hundreds, that might be even really lowballing it, of different kinds of tables. The analytics database generally does not need all of those tables. All right, we can pick some of the key data that we need. So for these reasons, because one, we may not want to tax this database. Two, we may just not want my business analyst having access to this database at all, right? You can mess with user data, you can see user data, right? Things like that. Three, because we can have this relatively fewer tables, or as we'll see, we can change the structure of the tables. We have a separate database, and that's going to be our Olap database. There's a fourth reason, which is literally the hardware, how this database, this OLTP database is powered. As we'll see when we get to Snowflake, is going to be different than how our analytics database is powered. So under the hood, these two databases will operate differently. You'll still be writing SQL with both of them. But like I said, under the hood, the way they operate, there are some differences that we can get into. All right, so generally what happens, and a lot of you have seen this already, is we'll need to migrate the data. We'll keep it, it'll stay here, but we also need to copy it over to the analytics database. So then we can do analysis on it. We can say build reports, meaning you can export data as CSV to give to data scientists or to business analytics. You can build dashboards, meaning you can connect this database to a BI tool, meaning business intelligence tool, Mode or Looker, Tableau, right? So you can kind of build these little charts, okay? And right, that's that's we can use the analytics database essentially to like query and build these reports. All right. So the analytics database, we will structure it not using OLTP. We'll use like a different model called Olap. So let me show you how this looks. So this is, not this, okay. So this is the Pagilla database. I wish I could, using OLTP. This is the old way, OLTP, right? Notice like lots of small tables. If you look at it, we're like keeping single source of truth. We have like a store, has an address, has a zip code. The address belongs to a zip code. The zip code belongs to a city. The city belongs to a state, right? This is kind of almost that same information, but captured in the Olap structure. So you can see fewer tables, right? We'll go through exactly what this is doing, but just off the bat, you can see like this is a simpler structure. There's fewer tables here. We only have like 5, okay? These tables are a bit longer, right? Notice that like this table here has 7 different columns here, okay? This one has another 6, right? So these tend to be a little bit larger tables than we had with our OLTP structure. And if you think about it, so why can we justify, I guess, like larger tables? Well, one, this is not consumer facing, right? Meaning people are not making actually updates to this data. We are instead pulling the data, right, in a batch, meaning like 1,000 records at a time, 10,000 records at a time over to the analytics database. It can happen overnight, and then people do the queries during the day, right? So we don't have to worry about throughput so much. What we have to more worry about, and even only to some degree, but people, I guess, do worry about it, is like the time it takes to make a query, not the time it takes to, say, create a new record, delete a record, update a record, okay? Rather, what we care about is how long does it take to make a query. That can be costly. And when you think about querying and the speed of querying, one thing that can take a long time are joins, okay? So when you have to join, if I have to figure out in this store what is the state that it's related to, and I have to join 5 different tables together to figure that out, that could take a long time doing the joins, all right? Because we can get into it later, but joins essentially are doing like a nested loop through the data. And they just take a relatively long amount of time. Here, you can see kind of this information is just stored directly on the store. So we are breaking that idea of like every key must point, that whole concept of what we call like normalizing the data or making sure this is only talking about one thing. Now this is not. In this store table, we have like the manager first name and manager last name. It's like a little bit loose, I would say. So this is kind of like in terms of why we're making a change here. So one, when we're moving to this analytics databases, optimize for queries, right? Not transactions. What that means is having longer tables or tables with more columns are okay because it minimizes joins and makes the tables, the queries faster because of that, right? It's also okay, and then we say we don't care as much about the cost of updating the tables because, meaning like making transactions, because these transactions are happening overnight, right? And they're not consumer facing, and they're happening in batches. Okay, when we like load data, we're doing that at night. It's okay. All right. Other things that are good about this, about kind of the structure, it looks easier to query, doesn't it? Like there's only 5 tables here. Everything seems like one away. So we have a sales table here. We have this, sales. We have dates, so we can see, when did this sale occur. So if we can find the customer by going to like the customer, using the customer foreign key, find the related customer. We can get the store. So everything all of a sudden is just one table away, like one join away from this center table called the sales table here. And we'll talk about how we achieve this a little bit later on. But you can see this is a simpler structure. So we have fewer tables. And why do we care about this? So this is reason A, optimized for queries, not transactions. We can say, the consumers or the stakeholders using the analytics databases may be non-technical, right? Or less technical. Meaning they could be like business analysts, data scientists, kind of some, it should be quite strong as SQL, but maybe not, They could be marketing, the marketing team. They all want to find out, and if we structure it, our tables in a more easily to digest manner, when all of a sudden they can kind of do the queries they want, okay? So this structure here, this is called the star schema because it looks like a star, okay? And basically what you start with is the way I think about this and organize this is if we have this Pagilla thing, where what is this? This is movie rentals. It's like, what are the key tables in this movie rentals thing, okay? So it's not, it's not the state, the city. Like these are, I guess, attributes of like where the rental occurred, but it's probably like the rental itself, is like the key thing we care about. That is the transaction that occurs. That is everything that we're describing. Or like if I'm managing this, everything I care about is probably like, all right, what are they buying? Tell me about the purchase, okay? There could be more than one kind of like key entity, but in this case, I think it's pretty clear. Like, tell me about the purchase, all right? And lots of times, the key table is going to be like this transactional table or where like an event occurs. There's no event that occurs with zip code, right? We're not creating new zip codes, but we are creating new like rentals. That is occurring, and we put that essentially right in the center. See that? We call it sales, I guess, but it's right in the center. And this is called, this center table where the event occurs, that's called the fact table. So I'm going to write that down. Okay. So notice with the fact table, I know it's a little small, but right, so we call it sales. We have the primary key ID. We have the date ID, the customer ID, the store ID. Everything on it is just a foreign key, okay? And then finally, the last thing is like price. So this is, if it's not a foreign key, it's typically going to be numeric and something that maybe you want to optimize for. Like, so for here, revenue. And maybe another e-commerce thing, maybe it will be profit. You could potentially have one, two kind of numeric values here. So maybe it's like revenue and cost, but probably, like having one is just fine. And what you can see, the way this works is you have the fact table in the center, and then around it is essentially describing the event. Sorry about that. So if we have like an event of, a sale, well then describing it is, who, what, where, and when. Basically everything but why. I guess that's a little nebulous. But everything else, like those typical questions, that's what's surrounding it. So the who, well, okay, this customer, okay? The when did it occur, right? That's this date. The what, right? That's the movie. What movie did they rent? And this is the where, what store. Okay, so like once you identify the key like kind of fact table, then I just go through those questions, and oftentimes that's what you can place around there. All right. Oh my God. Oh yeah, I got COVID, guys, but I feel fine. But my friend just texted me. Anyway, I'm basically over it. Yeah, I know. All right. So, the who, what, where, and when, you can kind of surround that. That's the surrounding tables. These are called dimension tables. One thing to like note about these dimension tables, look how many like textual attributes, right? They're more descriptive attributes than numeric, right? Like here's the customer, first name, last name, address, zip code, city, state. Notice also like in our OOTP, we would be splitting this out right? The zip code, city, state, we would have a separate table for them. Here, we're just keeping it there. We're doing the same thing with store, the address, zip code, city, state, the manager, first name, last name, right? We're like kind of losing something here. There's a many to many potentially with the store has many managers, but we're losing it by just putting the first name, last name directly here, right? So we are kind of collapsing things in an effort to make this simpler. To what degree you do that is, I hate to say it, like up to the organization, up to you kind of as a data engineer. What's important to me is like you recognize the trade-off that, we're losing something here. Movie, same thing. The title, the length, the language, all of these essentially are non-numeric. And then here's an interesting thing, dates. So with date, we could capture everything in this table in essentially one field, which is the date timestamp, right? Just like, all right, but instead what we're doing is we're breaking it out into the date, then the year, the quarter, the month, the day, the week. Why do we do that? Because now we can just join the table, join sales with the date, and then maybe like group by the year, and all of a sudden, and figure and sum up the price. And now I can find out yearly revenue really easily without having to worry about, okay, how do I extract, the year from the date, right? Especially if I'm non-technical. All right. So this is violating, just want to point this out, right? This is violating our single source of truth, right? Like we are storing the same information, right? Or information that's derived from one column in other columns, right? But we're okay with that. We are relaxing that requirement in favor of allowing us to make easier queries, okay? This type of pattern, it is, there's a reason why I teach it second. It's because like there aren't as many like hard and fast rules to it, right? So to me, the key thing is, okay, have down this OLTP structure. There is like a right and wrong to that. Then here, it's more important to like identify the fact table, start answering those questions of, okay, what's my who, what, where, and when, right? Kind of break them out. And understand the trade-offs, right? Understand, okay, like what if we had a store has many managers? How valuable is it for me to capture all the managers versus, for example, having the primary one? Here's the biggest trade-off that I kind of debated about, and still I'm not quite sure what's right. There's no way for me to capture like the shopping cart. You know what I mean? Like this captures a sale, an individual customer at a given time. But if you remember, I forget what it was called, our other OLTP database that had like that enormous schema, we had that idea of like a shopping cart, right? A person actually rents multiple movies at the same time, right? When they go to the cash register or checkout. And that's lost right here. Like we can get it by, I guess, grouping by customer ID and date, right? But like, I don't know, like that's a trade-off. Like what I would maybe do is add that as a table and now not strictly be like a star schema, but have that extra table of a shopping cart, right? So anyway, that's something, so it's just important to like see the trade-off and identify it, and that's something then you as engineers, you with stakeholders can figure out what's best. All right, so this is the Olap structure, and kind of like the key thing is like this star schema, where you have this fact table in the center, you have dimension tables around the side, but this is quite different than our other OLTP structure. Questions about this? Yeah? All right. This is something I would take notes on. I would like take a minute, like think through the differences between these. All right. So I will. Okay. Yeah. So it's these three readings. It says Olap cubes. I don't know. I think the topic name doesn't really line up. And then I think this you can probably read on your own. The Olap Cube reading and the Olap Cube lab. I think you're pretty good for understanding that and moving through that. And then if you move through all these, then we can deploy material and CTEs. All right. This is also like you may hear these tables referred to as like MART tables. We're gonna talk about that term later on. But if you hear the term MART tables are often in a star schema. MART tables means like these are the tables that non-technical stakeholders will be querying, right? Like when we kind of, we need to place the data, somehow get the data from this structure to this structure, right? And this is like the end product that we deliver to non-technical stakeholders, right? So that they can query the data in an easy manner, all right? So you may hear that term. And I'll just write it out. It's like MART, as in MART tables, and then it's like data mart. Okay?